Hello everyone. This video will show how to use the left Riemann sum to approximate the area under the curve of a given function over an interval. Now let's go over this example. Approximate the area under the curve of this given function right here on the interval 1, 10 using the left Riemann sum with 3 sub-intervals. So what are we going to do first is to label the interval that we wanted. So here it says that it starts on 1. So I'm going to go ahead and say that this is our 1 right here. I will label this as A. And it goes all the way to 10, and I will label this as B. So what we do next is we are going to divide or partition this portion from A to B into rectangles so that we determine the area of the rectangles, and that would approximate the area under this curve. We remember that the area of a rectangle is length times width. So we're going to go ahead and determine the width of the rectangles that we're going to create from A to B. So let's define the width as the delta x. The formula for delta x, which we represent as the width of the rectangle, is delta x is equal to B minus A over n, where n represents the number of sub-intervals. So we go ahead and determine our width for this problem. So we're going to start with B, which is 10. So I write 10 minus our A is 1. And then that is over the sub-interval n is 3. So this would come out 10 minus 1 is 9 divided by 3 is 3. So that means the width of each of the rectangles that we're going to create from A to B will have a width of 3. So we go ahead and draw these rectangles. Since we say that this is a left Riemann sum, we're going to create rectangles whose left endpoint or the left side of the rectangle is touching the graph. So what are we going to do is we're going to start with A. So I'm going to go ahead and create that first rectangle. Now we remember that since this is a left Riemann sum, the left side again of the rectangle touches the graph. And we know that the width is 3. So I'm going to count 1, 2, 3. So this is the first dot right here that touches the graph. And so I can go ahead and create that first rectangle. And if you notice, the left side of this rectangle is touching the graph because again, this is called the left Riemann sum. And then we go ahead and draw the second rectangle. So it's going to start from here. So this is where we're going to start. So that's the left side. And then we count 3, 1, 2, 3. So it's going to go all the way here. So we can go ahead and draw the second rectangle. Again, if you notice, this second rectangle, the left side is touching the graph because it's the left Riemann sum. And then for the third rectangle, again, the left side of that rectangle should touch the graph. So I'm going to create that dot right there. And then the width is 3, 1, 2, 3. So it's going to go all the way up here. So these are the rectangles that we're going to use to approximate the area of this given function from the interval 1 all the way to 10. Now we remember that our delta x that we created at the beginning is actually the width of this rectangle for each one of them. The next step that we need to do is, again, since we know that the formula for a rectangle is length times width, we already have the width, which is delta x in our case, which is 3. Now we're going to determine the height of each of these rectangles. To determine the height, we are going to find the value along the y-axis that matches up these dots. So what we do for this first one here is that we're going to look for f of 1. So our x is on the 1. So that would be f of 1. In this case here, this will be f of 4. So we're going to look for that height here, which will be f of 4. And then we're going to look for the height of this one, which is going to be f of 7. So the values for each of these will represent the height, and we are going to solve for each of them using the equation that we got right there. So we're going to start with f of 1 first. So I'm going to go ahead and write that up here. So f of 1 would be equal to, we plug in 1 to the x here. So that is 1/4 times, our x is 1, and then that's a minus 3 squared plus 5. So what we do is we just go ahead and simplify this. So this would be 1/4 times 1 minus 3 is -2, and that's a squared plus 5. And so we can simplify this further, which becomes 1/4. -2 times -2 is +4. And then plus 5. So if we simplify this, this would be 1/4 of 4 is 1 plus 5 is 6. So that is the height of this first rectangle. Now let's solve for the height of the second rectangle, which is f of 4. So we do the same thing. We are going to plug in 4 to the x. So that would be 1/4 times 4 minus 3 squared plus 5. So that is 1/4 times 4 minus 3 is 1, and that's a squared, plus 5 is equal to, that's going to be 1/4 of 1 plus 5, pretty much like 1/4 plus 5. So 1/4 is 0.25 plus 5 is 5.25. Now I'm going to do the next one right here, f of 7. So these are the heights of these three rectangles. Now what we do next is to find the area, again using the left Riemann sum. So all we need to do is to use the formula. So the formula is area is equal to length times width. So our width is delta x. So that would be delta x times, for our length, that would be the summation of all the f of x's. So we're going to add all these f of x's values that we got here. So our equation would come out. Our delta x again is 3. We got that from there. And then multiply that by the sum of each of the f of x's. So that would be 6 plus 5.25 plus 9. So if we do the math here, this would be 3 times 20.25, which will give us 60.75. So this is the approximate area for this given rectangles that we have here. And this also would represent the approximate area under the curve from the interval 1 all the way to 10. So that is how we use the left Riemann sum to approximate the area under the curve of a given function over an interval.